So one of the things we're doing in experiment 1 is we're doing a titration of an unknown buffer, and in essence, I call this buffer testing. We're going to give you 4 different unknown buffers. I tell you in the handout what they are, the identities, the potential identities of the 4, and then I also tell you that there are three of them are actual buffers, and one of them is water. And then I also tell you that the concentrations are limited to, it can be 25 millimolar or 50 millimolar. Those are the 2 possible concentrations. So what I want to do is I just want to go through in this video and demonstrate using kind of a generic example of how you do this buffer testing if you're unsure of it. So in this, we're going to suppose that we're titrating 50 mils of an unknown buffer, and we get the following results. So here the results are basically going to be volume, right, and pH. But what I've done is I've gone ahead and I've converted volume into micromoles, and I'll show you in a moment how I did this calculation. But I've basically set up a formula here, calculated micromoles from the volume, and then of course for each volume I have measured a pH, and that's what I've plotted here in my titration curve. Now in my titration curve, basically what I'm seeing is I see the pH starts off at around 4.6, and then it goes up quick, kind of rapidly to about 5.9, and then it sort of levels off, stays pretty level, and then all of a sudden it starts to kind of jump up again. And so what I'm going to consider this jump point here is my end point. So you can see the next data point, it kind of starts to level off again. That means I'm just getting outside the range of my electrode. It's not measuring very well past 11 pH of 11. So here I'm basically going to trust this as my endpoint. So if I take this as my endpoint, I can come back down to my data, and I can say, okay, well, what does this correspond to? And unfortunately, hold on just a moment, let me move this out of the way. There we go. I was wondering where my numbers went to. And so what you can see is that here, down at the bottom, I'm plotting in this plot micromoles on the bottom versus pH. And so right around here, I'm looking at 5,000 micromoles, and that's 5,000 micromoles of hydroxide. So I've added hydroxide, and I have 5,000 micromoles that I've added to get to this point. So if I go to half of that, that's going to put me here at 2,500. And so that would be the midpoint, or also would give me the pKa. So the pKa in my plot is actually this 6.89 is my pKa. The equivalence point that I was just referring to is basically this point right here. That's the 5,000 that just corresponds to this point, this data point up here that I was talking about. So I get to the end point, and I can see, okay, well, let's go to half of that number of moles. That's half, basically the equivalence point of 0.5, a 0.5 equivalence point. And then basically then I know what the pKa is. Now the pKa is what's going to give you the identity of the buffer. So right now this is the closest to 7. It's about 6.9. It's closest to 7, which is about where I expect my phosphate buffer to titrate. And so here I could identify with this pKa that this is my phosphate buffer. Okay, so that's one thing that I am asked to determine is which buffer is it. And so I get phosphate because of the pKa is about 7. Now, how do I determine the concentration? So let me come down and show you the calculation that I've got down here. Now, this first calculation is just simply how I calculated the number of micromoles in 100 microliters, because that's the increments that I added. So if you look at my data, I add 100, 200, 300. You're going to add 25, 50, and so forth. So you'd have to do it with the appropriate volume. But the concentration of sodium hydroxide is 5 moles per liter. So it's 100 microliters at 5 moles per liter. I'm going to convert that volume to microliters, and then basically I'd be able to cancel out liters, and then ultimately, because I'm multiplying by this factor, 1 liter per 10,000 or 10 to the 6 microliters, These microliters will cancel out. Then I want to convert my moles into micromoles. So ultimately you can see basically the 10 to the 6 also cancels out as well. So I wind up with 100 times 5, which basically lets me 500 micromoles. The 10 to the 6 and 10 to the 6 cancel out. Okay, so that's just the 100 microliter increment is 500 micromoles. So what I found though from my equivalence point was that I had 1,000 microliters added, which is equivalent to 5,000 micromoles of sodium hydroxide. And so if I want to know, I get to the equivalence point, I've added one equivalent of base at the equivalence point. So one equivalent of base is 5,000 micromoles of OH minus. However, that means I've also, since I reached the equivalence point, I know that I had in my original solution 5,000 micromoles of what I was titrating. Okay, in this case, phosphate. So I'm titrating 5,000 micromoles of phosphate, and the total volume that solution was that I titrated was 50 mils. So to get the concentration of the solution, I take the number of moles that was in the solution, so this is micromoles of phosphate, divided by 50 mils of solution volume. I'm going to convert my micromoles to millimoles with this conversion factor, and then I'm going to convert milliliters into liters because I want units of millimolar, and millimolar is per liter, millimoles per liter, right? That's what I want. So that's why I've done this, set this problem up this way, and you can see now I say, okay, I've got a phosphate buffer, and it's approximately 100 millimolar. And so I've determined the identity using the pKa, and then I've identified the concentration in these calculations here, where I take the equivalence point, the how many micromoles of base did I add? However many micromoles of base, that's the same number of micromoles of thing that I titrated, whether it was glycine or phosphate or acetate. So 5,000 micromoles of whatever divided by the 50 mil volume that I titrated, do some conversion, and I can get it to millimolar this way. And that's how you would know, determine the identity and determine the concentration of your unknown buffer.